Surgical medic on your screen. So okay, we'll be going into atomic structure, just like a continuation of what we did already in the last class. So if you've not watched that of part one, you might be lost. You might be lost when you hear me talk about this my guys. So we talked about some other guys there. So this one is just a continuation. Are you with me? So this is okay. So let's quickly do a quick recap before we now come to all these people here. Now a quick recap of our last class, and I'm back today with you know a lot of funny mnemonic from my mnemonic bank, from my mnemonic book. Sorry. All right. So okay, in the last class we talked about J.J. Thompson, where I told you what he did, and your J.J. Thompson actually, and don't forget your what John Darton said. You know that it was John Darton that was saying that the atom is not actually divisible, and after now our modern idea of the structure of the atom made us understand that the atom is divisible into pen. Are you with me? pen, pen. So we'll go after all this. Our scientists will talk about this modern idea of the atomic structure well. But one thing is that Dalton said a lot, you know a lot about this atom of a thing, and we found out that many of what he said is inaccurate. Like they are not correct at all. That is why all these my guys now stood up and say, no guy, all these things you are saying, you are lying. So the one that discovered discovered the electron. The one that discovered the charge of an electron discovered the charge of an electron. The one that discovered that discovered that. Now in the last class I now told you that JJ Thompson model of the atom. So from my mnemonic bank, I call the name of his own experiment WEP. Let me use my second marker. All right. So I call his own WEP. My whelp. That's WEP. My W is telling you that the name of his experiment is watermelon. What? Watermelon model. E here is telling me that another name for his experiment is what? The electron model. Electron cloud. Model. Then my P is telling me another name for his model again, which is what? The plum pudding. So don't be confused when you see all these names in your CBT on that day, and you now be like, which one is plum pudding? Which one is electron cloud model? Why is this thing logical? Why is it tricky? It's not tricky. If you know that your WEP is what J.J. Thompson did, then you are very, very good. Now, do you remember that this same guy was the one that brought this cathode ray experiment, something his own, coming from your discharged tube experiments? And this cathode ray, he told us a lot of things about this cathode ray. How that they would actually move on a straight line, how that they will have constant charge to mass ratio, how that they will attract positive charge, and how that they will possess momentum. All right, you'll be like, which one is all this story that this guy is saying? It's not a story. Let's use another mnemonic for this cathode ray. The mnemonic I would use for this cathode ray, let me use my red pen, will now be my champ. CHAMP. I believe you two, you have your mnemonic bank where you are keeping all these mnemonics so that you can revisit. You cannot just use mnemonic abi. Okay, you taught us mnemonic now and you can write, you just put it on your head, then expecting one magic somewhere that, okay, let me just I will remember. You have to write it. Have a separate book. You can name your own book too. Chemistry secrets. That's what I mean. I have my own book I wrote, where I called it the chemistry secrets. So, and I don't know if you need the book, you can just message me. That's my number up there. just reach me, feel free. Alright, so CHAMP, CHAMP, alright, these are the properties of its cathode ray. When he discovered the cathode ray experiment, blah 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 blah, and the characteristics of his cathode ray was CHAMP, which is our CHAMP. Now, what's the meaning of this CHAMP? Let's write it out. CHAMP, 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 CHAMP. Okay, let me use my blue pen here. Then coming down, so my CHAMP is C. Okay, CHAMP. Now let's take it one after the other. Now my C here is telling me that they have constant charge to mass ratio. Are you with me? We have constant what? Charge Q, Q to mass ratio. Like they have constant charge to mass ratio. And I even explained, I went further in the last video to like tell you this charge, this value, the value. So I don't think I should do it here because we have a very long way to go. I still need to explain all these things, and I don't want the video to be that long. Yeah, so just check the previous one. You can just check it. We don't need to still be going into all this one today. Share you get. I've done it before. So where my charge is 1.6 exponential minus 19, the mass will be 9.2 exponential minus 31. Then you divide and you get your answer, which is 1.76 exponential 11. I still even remember. So H here, H is telling you that they have, they are negatively charged. Share you get. They have constant ratio of 1.76 exponential 11. The value we got from this year, so H is telling us that they have, and A here is telling us that they attract positively charged particles. And how do we know that they attract positively charged particles? Since J.J. Thomson actually discovered the electron, and you know your electron is negative, right? So since you know that, this thing is negative, you should have known that no, this cathode ray, since this ray, all these things, since its experiment is negatively charged, it's actually going to like attract the opposite charge, which happens to be your positive charge. So that's it, attract positively charged particle. Now your M there is telling you that it's moving, like these particles, these rays are moving on a straight line. Are you with me? Then P there is telling you that they possess what? Momentum and kinetic energy. They possess momentum and kinetic energy. They possess momentum and kinetic energy. So this is just a quick recap. So and that's that. So you have, this is the name of his experiment, WAEC, which is the watermelon model or electron cloud model, or you can still call it plum pudding. And the characteristics or properties of your cathode ray experiment is your CHAMP, constant charge to mass ratio. They have constant ratio of 1.76 exponential minus 11. Let me write it again, 1.76 exponential 11. So this is it here. They have a constant ratio of 1.76 exponential 11. They attract positive charge because they are negatively charged, and they move on a straight line. Then they possess momentum and kinetic energy. As you can see, it's very easy. Now that's about J.J. Thomson. Now we move from J.J. to this second guy that they were in school together then. We were in 100 levels together then, and his name is Robert Millikan. Robert Millikan did not know book like that. I was the one teaching him book then. No, sure you get. I was the one actually teaching him book then. So, but then let's see, what did he do? Robert. So Robert Millikan. So Robert Millikan, the name of his own experiment is oil drop experiment. Please take note. I said it in the last video, so this is just a recap. So he did his own, like, his oil drop experiment, and he now determined the charge of an electron. And the charge of an electron, that this guy that I did not know, that I now taught him then that, okay, you don't know the charge of an electron, I will teach you. Sure you guys. And I taught him. Now I said that okay. What's now the charge? And I told him that the charge is what? 1.6 exponential minus. Please take note of all these things. So coulomb. So that will be now be charge of an electron, and it's the one that determines it after I taught him. So that's for Robert Millikan. Then now the Ernest. Ernest is my guy. He was in 300 level then. Ernest Rutherford. See this Ernest Rutherford in here. This Ernest Rutherford, what did he do? What he did was actually very simple. What he did was actually very simple. Rutherford actually brought tin gold foil, like a tin gold foil like this, and he now introduced, something which is, let me use my second marker. He now introduced this to this, like he bombarded this gold foil, this gold foil, this gold foil. He bombarded it with what? Alpha particles. And you now notice that, okay, maybe let's say 1, 2, 3, 4 alpha particles was bombarded. And now he discovered that, plenty of these alpha particles will pass through, this gold foil particle, this thing, and just few will be deflected back. Out of 4, it might be only one that will be deflected back. So if you have anything that will deflect from here, it will be very few. And that's Ernest Rutherford experiments. So after, in a bit to explain this gold foil or alpha scattering experiments, he now brought about like the planetary model, like the nuclear model. She gets nuclear model, where he told us that at the center here is, is having the plus, the cloud stuff. And he now told us that, okay, this center here is what is called the nucleus. And inside this nucleus, we found out that there are protons inside. Are you with me? Protons inside. And it's not only a proton that is inside. He said proton is inside and neutron. And this constitutes what? The nucleus. He also made us understand that there are a lot of masses here, that the mass are concentrated around this nucleus side. And now told us about the extranuclear parts, like what is outside the nucleus. That the stuff that is outside the nucleus is your electron, like outside the nucleus. That's the extranuclear parts. You now find your electron, and that's why he call it the nuclear model, or the planetary model. Sure you get. So that's about what Ernest Rutherford did. So all these guys here, they are my guys. Now in today's video, we now want to go into what all these guys did. These guys 1, 2, 3, 4. What they did. Now also, I think we have some laws. Let's add, some laws you need to know, like your Pauli exclusion principle, your own rule, and your S badge uncertainty principle. I will chip that in under what he did here. So just follow closely. I think, let me clean this part so that we can be able to express ourselves very well. Yes, my guy. You see that guy, that guy is a good guy. Seriously, he's a good guy. So yeah, the board is clean. Yeah. So the nearest ball, actually, nearest ball here was his own model is called quantum model, just like others add their own name. Others add, like JJ Thompson now, they call his own WEP, WEP. That's your watermelon model, electron cloud model, non-pudding model. So yeah, so then Rutherford model, that's the nuclear model, and the planetary model, that's from your nursery and primary school, NP. Sure you guess, that's your Ernest model, that's nuclear model and planetary model. So here, Niels Bohr model is not your oil drop experiment like Millikan. Take note. Here his own is quantum model. Quantum model. And you see this Niels Bohr, he was actually doing a building up on what Ernest Rutherford did already. What did Ernest Rutherford did? He explained the nuclear model of this atom. So now this one now came, he re-explained it and now added just few things to it. That they just elaborate a little. Just added small stuff a little. So what he said, the center, the very center is called the nucleus. just like in your animal cell and plant cell, where you have the center as well as the nucleus, and that eukaryotic organisms are actually, they having a nucleus and a membrane bound organ, and the nucleus will be at the middle. So just like that too, he said the nucleus, like at the middle here, you have your nucleus, and the nucleus, inside the nucleus, you now have your neutron and proton. Your inside the nucleus, you have your proton and your neutron. And how do we know that it's proton that inside? Because it is positively charged. And you know that your proton is actually, positively charged too. So from there, now say, you know that this is actually what Ernest did. So he now added that. So this thing, they are now in orbit. Like they are in orbit, that or shell, or or energy levels. Energy what? Levels. Are you with me? So after I explained the nuclear model, I said they now exist. So like they exist in orbit, in shells, in energy levels. So alright, now when they are talking about shell, they are just talking about what houses, you know, your electron. You know that your electron will be located in the extranuclear part now, just like I explained under Rutherford. The extranuclear part, normal lemma like this, your extranuclear part. So since it's located at the extranuclear part, it is actually wounded around your shell, and that's what brought us to naming of shell, which is your K, L, M, N, O, P, Q, and blah blah blah. So this is the name of our shell, in which it will be given as, let's call this one our energy levels, like N, which is called principal. So yeah, your principal. So just the number assigned, sure you get. So the number assigned to this one is like your first shell, your second shell, M will now be your third shell, N here will be your fourth shell. Are you with me? O here will now be your fifth shell. P will be your sixth shell. Blah blah blah, down 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 like that. Sure you get. So then we now move to, how that these people would have maximum number of electrons. So Neil made us understand that the maximum number of electrons in the K shell is what given out by 2n squared, because 2n squared is normally the formula, like 2n squared, that's the maximum number of electrons that you can see in a given shell. Now let me explain. So coming back here in the K shell, what will be your maximum number of electrons in the K shell? Fast, what will you do? You write your formula out, that okay, 2n squared, what will be my distance? So my n here is 1, right? That means 1 will be here. So that's 2 into bracket of 1 square, which is what? 2 multiplied by 1, which is what? 2. So 2 will be my maximum number of electrons in my K shell. How do I mean? Now, this is what I mean. Your very first shell, the very first one, like your K shell, this is your K shell now. And this K shell is the one that houses my electron. And we found out there is only 2 electrons that is here, E and E. So that's what we mean by our 2n square here, that we used to get our 2. I don't know if you guys are getting me. Can we now do for the L now? And I believe you can do for L. Let me just do for L and M, so you can understand it very well. So you do for the rest by yourself. So now for L shell, what will be this L shell? So like this is K, then my L shell like that. This is my L shell. Now how many? What will be the max electron in this L shell? What will be the max electron in this L shell? I don't know, but I will know since I know my formula. My formula is now 2n squared. Let me quickly look for it. 2n squared, in which my 2 into bracket of my n is what? My n is 2 squared. So 2 multiplied by 2, that's 2 by 4, that's 8. That means the here my L shell would be having 8 electrons. That would be electron 1, electron 2, electron 3, electron 4, electron 5, electron 6, electron 7, electron 8. Can you see that chemistry is actually extra simple? So you should do for your M shell do for your N shell, I want to know the maximum number of electrons in all these remaining shell. You can as well do and drop your answer in the comment section. This would energize me to do more videos for you. But if you choose to just watch and not drop your answer, then me too, I will not do any video anymore. So ensure and ensure you subscribe, so that you will be notified when I drop another video. Something called your ground state and your excited state. Then we, like, how do we get, it's coming from your n, this thing, your number of shell, which is your k l m n o, which is your number of shell is 1 2 3 4. Now sure you get, I hope you understand from what I just explained now. So don't be quick to forget anything here. So all right, your KLMN, right? We now have what is called our ground state. And so you see this number 1 here, this very first number is the number on the ground, because it is the lowest, lowest energy level, like your lowest shell. So this lowest shell is one that is called ground state, GS, like ground state. Why the rest starting from 2? So any number that is higher than that one will be your your excited state. So that means your 2 is excited state, your 3 is excited state, and then your 4 is excited state. So if you now have blah blah blah, like your OPQRS shell, that's maybe your 5 6 7 8 shell, they are also your excited state. So you see that the only number 1 here, this only lowest one, is your ground state, the one that on the ground, the one on the floor. So you now get like that. So now there's something called energy being absorbed or energy lost. Sure you get. Now what is energy lost? Energy is when, this is your lower level, this is your higher level. So when an electron jump from your ground state to your to your excited state, we simply said, okay, this thing has gained electron. Sure you get. It's that means it's absorbing, it's gaining. That's from 1 to 2. But if it is losing, that means it's coming from your excited state down back to your ground state. Please take notes. All these things are extra simple. So I just okay. Let's move. Now these guys, my beautiful guys, all these people were in, when I was in primary 6 then. They were in primary 20. Sure you get primary 20. So you see these 3, they are in primary 20. 1 2 3 of them were in primary 20. Primary 20. Oh my god, primary 20. So but then let's check few things about them. You see, these 3 of them, they are the one that did our WMM, wave mechanical model. Wave mechanical model. What do I say? Wave mechanical model. Wave mechanical model. And this wave mechanical model, each of them now brought about something. What did this one do? This de Broglie, hey my brother, he did WPD. That's your wave particle duality of matter. That's what de Broglie did. So I don't think I need to go so into details, so that you can watch my next video. Is in that next video that I'll actually explain what this my brother did. So anticipate, because if I say it here, you might not want to watch that one. So yes, air sim badge actually, to like explain the uncertainty of our electron, where he brought us a principle that we cannot determine, the location. Alright, we cannot determine the change in x, that's the location, and our momentum with certainty, and we call his equation asymptotic uncertainty. So this is how he used to write it. This is how that guy used to write it, and I was the one that teach him actually. I taught him too then. So I told him that you will do like this and write your h over 2 pi. So very simple. He said, for we cannot determine the momentum. That's changing. P is momentum. Now under physics, go and watch it. I've done it too. So the momentum and your location changing x from your physics. So your location with certainty. So your PM, you cannot, your pulmonary vein from PM, you cannot determine it with what? Certainty. You cannot determine the momentum and location or position of an electron with certainty. Please take note. Then my guy Erwin Schrödinger, Schrödinger now brought about the wave equation. The wave equation. We'll be talking about our Hamiltonian stuff, blah blah blah. Check in the next video, you'll meet it there. That's your Erwin Schrödinger. So all these three people brought about our wave mechanics model. Wave mechanical model. Are you with me? Then, alright, from there we have our Pauli exclusion principle, which states that like guy said, and I quote, no two electron can have the four quantum number, can have the same value of what? Four quantum number. And then how do I know my four quantum number? I made a video already on quantum number. Go and watch where I said it's our palms, our principal, azimuthal, magnetic, and spin. Can you see that mnemonics are powerful? Can you see? I even remembered. So palms. So then no two electron can have the same four quantum number. No two what? Electron can have the same four quantum number. And then Undru said electron must occupy each orbitals singly first before pairing take place. That means I must first occupy singly first, 1 1 1, before I now come back and pair 2 3. Sure you get? Maybe when you're writing for 1 3 4, you're writing for your 3p5 now, 3p5, like this 5 electron here, 5 5. So you have to occupy singly first. That's 1 2 3, then 4 5. Sure you get? That means this one will not have anything. So like electron must occupy each orbitals singly first before pairing now take place. That's what Undru said. So let's come to an end of this video. But before we come to an end, let's discuss about the modern idea of our atomic structure. And before we go there, there are some calculations under this, wave mechanics model, where you have your palms, where you be determining your this thing. I think coming from Niels Bohr, you be telling us about the value of your principal, the value of your azimuthal, your magnetic, your spin. This calculation in chemistry is extra simple. Trust me. Just go and check that video on quantum numbers. I made it already, and it's extra simple. Just go and check it. Don't worry. Then under this Niels Bohr, Niels Bohr has a series. He has a series, and this series I think is for advanced level, but let me give you before I go. I am bringing a mnemonic from my mnemonic bank for this series, because he told us about this series and he said, Lord, please bring possibilities back. Lord, please bring possibilities back. Let me clean the board so that we can have. Lord, please bring possibility back. Like a series or nearest series. Let me write it for you. Nearest series. So under Niels Bohr, now said LBPBP. Lord, please LPBPBP. Sorry, Lord. What am I writing? Say, Lord, let me first write it first. Bring possibilities back, please. We are begging you, please bring possibilities back. Lord, please. Lord, bring possibilities back, please. That's your LBPBP. Lord, bring possibilities. We are begging you. Lord, bring possibilities back, please. Let me have 390 JAMB. Lord, bring possibilities back, please. Now, what's now the L there? We don't need to have shouted too much, so you should have made it like that. So your L is your Lyman series. B is your Balmer series. Then this one will be your Pascman series. Then this one will be your brackets series. Then P here will be your P fund, like your fund. your front series. Shey you get like that. Shey you get like that. Shey you get like that. Your Lehman, your Bama, so your Pascman, your brackets and P4, that's from your Lord. Bring possibilities back, please. Bring possibilities back, please. Bring possibilities. So now I think that's like that. Let's now go into like the, what is it called now? The modern idea of the atomic structure. The modern what's the modern idea of atomic structure? From that thing said we cannot divide this thing into three, but our modern atomic structure, it was divided into PEN, pen. Please follow closely. PEN, pen. And this PEN, pen, actually he said this P here is proton. No, why that thing was saying nonsense? E here is electron. No, that thing was saying nonsense. N here is neutron. No, it's not saying it's not divisible. Why is it not divisible? Now they now told us that what's the charge? They told us, those my guys told me that the charge for proton from the word P is positive, from the word E negative. Since you know that P is positive, then definitely your electron will be negative and this one will be neutral, no charge. Shey you get? Neutral, no charge, neutral. Now what will be your mass? This one is your charge, sha. This one is your charge. Then your mass. What will now be the mass of proton? That's your, what's the mass of proton? Oh, the mass of proton, that's your 1.67 exponential minus 27. Please take note of all these things, especially post UTMites. If you know you're actually going to be writing post UTME soon, all these things they might not give you. You just assume that you know them already. Then your electron, what is the mass of an electron? That's your 9.1. I said it in the last video too. I've been repeating all these constants. Please take them. Take them, know them. 9.1 exponential minus 31. Then that of neutron will be 1.68. That's 1.68 for neutron. And same exponential. Sure you get. Now what will now be the relative mass? The relative mass is different from the actual mass. This is the actual mass in kilogram. The actual mass in kilogram. Then the relative mass. The relative mass of proton is 1. The relative mass of electron is 1. But that of, sorry, and neutron is 1, but that of electron is not 1, is rather is 1/840 rather, 1/1/840 rather, sorry, 1/1/840. Please take notes. I'm trying to, so sorry that I'm trying to rush. Just take note of all these things. Take notes. So that's that. So, and the modern atomic structure is actually just telling you about how that you're actually going to, have a circle. You have a circle, and then in this circle, now in this circle, the one at the middle, like there will be there are some things, some charges that will be concentrated at this center. And what is that charge? That charge is what? Positively charges. That's why he now told us that inside this place, this center, we have our proton. Because of all this plus, we have our proton, because you know that proton is actually positive now. Proton is positive now. So he told us that this place we have our proton plus neutron. Please don't forget, proton plus neutron. And we call all this center, we call it our nucleus. The extra nuclear part, which is this part, this extra nuclear part outside there, is surrounded with what? The electron. Very simple. So it was Niels Bohr that now told us that all these electron and blah blah blah, they are in energy levels. There's even one thing I forgot to mention, how that Niels actually determined the atomic spectral line of hydrogen. Sure you get. I forgot to explain that. But then let's just move. Let's move. So now after this, so what again? Should we call it a session? Or are there more things to say? Alright. So the nucleus is, check how we represent the atom of an element. How do we represent the atom of an element? For example, let's assume this is an atom like this. So they said we would represent an atom with, we'll assign a number. That's Henry Moseley. Henry Moseley was one that said it too. That will assign an atomic number and then we assign another thing like mass number. So here will be our atomic number. Let's call it Z. Let's just assume it's Z, and here let's assume it's M, your mass number. So alright, now you see this Z here is actually your atomic number. Are you with me? Your atomic number, or we see you call it, this one is your atomic number. Let me write it. Your atomic number, or your electron, your electron, or your proton. Are you with me? Or your proton. So if they ask you what is the proton number in these elements, for example, let's use real elements, 11, 23. Are you with me? What is your proton number here? Your proton number here is 11. What is your electron? Electron here is your 11e. 11 electron. Now simple. And what's your atomic number? 11. So this Z here is still your electron number, still your proton number, and still your atomic number. Now what's your mass number? This is your mass number here, up here, and your mass number is given as your proton plus neutron. So your proton plus neutron is given as mass number. That's why they call it, like, the definition of mass number is that mass number is sum total of proton and neutron in an element. So if you have an element A having atomic number Z and mass number M, if you want to calculate your mass number, you plus your neutron and you find the sum total of your proton and neutron. Now, for example, in this element sodium here, this atom here, how are you actually going to find the neutron here? Very simple. If they ask you to find your neutron, now how will you find it? You go to your formula. My mass number is equals to my proton plus what? My neutron. And my mass number here is 23, equals to my proton here is what? 11 plus the X. We are looking for neutron. Don't forget, we are looking for neutron. So this is what we are looking for. So that means my X equals to 23. If equals to go and meet plus here, it will become what? Minus. So minus 11. So S is equals to, so 23 minus 11. That's, we have, our 12. Sure you get our 12. So here our neutron is what? Our neutron is what? 12. How do we confirm if it is correct? Just let's check. You know that our mass number is equals to our proton plus neutron. So my mass number will be equals to, what is my proton? 11. And what is my neutron that I got? 12. Plus the two together, I will have 23. And 23 is what? My mass number, as you can see. So these things, they are very, very simple. They are extra simple. So we have some of my guys, that actually, they did small stuffs. They did small stuffs, more stuffs, like, our renting now. Renting actually was the one that actually discovered X-ray. Williams Renting discovered X-ray. Our Henry Moseley actually assigned atomic number to elements. So our elements, atomic number, shey you get. And then our Democritus was the first man to discover the atom, from the word atomos, which means indivisible. That's Democritus. Then we still have a lot of people. My guys are plenty. Basilius family. So Basilius is the man that actually, like, assigned a symbol to elements. Sure you get symbol to elements. Then that's all. Let's call it a session already. Let's call it a session already. Let's call it. It's 38 minutes. Let's